Let's take a look at some more word problems. Problem solving, direct translation problems involving percent. And get my first problem up here. There it goes. And this one says, what is 80% of 320? Now, a lot of books will have formulas for this, and really when you're dealing with very basic percents, it's better just to kind of read it and write it from there, not to try to apply some kind of formula, because you change it a little bit and it doesn't fit the formula exactly anymore. Well, wherever we have an is, that is our equals. Now what is our variable? Now the of is times. So this is saying 80% times 320. Like that. And now we're ready to solve this. Now, you never work with them in percent form. You immediately want to change it to decimal. Now, to change this to decimal, if I were to put a decimal place on the 80%, the decimal point would be right there. And to change it from percent to decimal, you move your decimal place 2 places to the left. So this would be 0.80 or 0.8 times 320. 256, I think. Let me go over my calculator and double check that. Let's see, 0.8 times, I'm not very good with decimals, 320, 256, yep. And that'd be your answer. Let's take a look at our second problem. %70 of what number is 77? Well, again, where the is located is our equals, so that's equals. And there's a 77 after the is, so I put 77 after this. The of is our times, so that's saying 70% times, and then what number is going to be our x, like that. Now again, we want to change that to decimal form, so 70% would be here. This is where my decimal would be if there was one. So I move it 2 places to the left. So this becomes 0.70x, or 0.7. Remember, if you got zeros at the end on a decimal, you can drop them. And we'll divide both sides by 0.7 to get the x by itself. And those going to cancel. And I think it's 110. 70% of what number is 77? That seems very reasonable. But let me double check. Again, I do not like decimals. 77 divided by 0.7. 110. Yep, that's our answer. Take a look at one more of those. $25 is what percent of 80? Now again, where is our equals, so this is an equals. 25 is before that, so I put 25 before the equals. The of is our times. What percent, that's going to be our x, times 80. So I'm going to go ahead and divide both sides by 80 to get the x by itself. X times 80 is just 80x. And do that, those are going to cancel. And we get 25 over 80. Drop my pen. Let me get it. There it is. Got a special pen for this little tablet. Okay, 25 divided by 80. Let me put that in my calculator. 25 divided by 80. And we get 0.3125. Now this is asking us for percent. Well, this is in decimal form, so we need to convert this back to percent, and we do that by moving our decimal place 2 places to the right. So this one will become 31.25%. And that's our answer. Now these next problems, let me bring up one, kind of give you the idea. It says the sales tax is 6.25%. Total cost of purchasing a used car, including sales tax, is this. Find the cost of the car before sales tax. What these revolve around, let me start a new tablet here. There we go. Is there's two forms. One of them is where we got an amount plus an amount times percent equals your total. Now this is where you got the price of an item in a store, for example, plus the price of the item times sales tax rate. Maybe the sales tax is 7%, and then that gives you your grand total. So this adds on to our cost. Sometimes in business they talk about markup, where they're marking up the cost that they're getting by 20%. That's also increasing it. So this is sales tax problems, markup problems. You also have another type that says your amount minus your amount times a percent equals your total. Okay, a price in a store is $50, and they want to knock it 10% off. So you take your 50 minus your 50 times 10%, and that gives you your total. So these are the two type that we're talking about when we're talking about increasing or decreasing an amount by percentage. This one here is like a discount. You have to read the problem to see whether they're talking about adding or subtracting. So let's go back to this problem now that we've talked about those. Sales tax is 6.25%. Total cost of purchasing a used car, including sales tax, is that amount, and then it says find the cost of the car before sales tax. So sales tax adds on. So we're going to have cost plus our cost times our tax rate is going to give us our total. And I'll put total cost. Okay. Well, they give us sales tax 6.25%. So I put 6.25% there. Total cost, including sales tax, is this. So $5,312.50. And they're wanting us to find the cost of the car before the sales tax. So they're wanting us to find this. Well, this is a variable. So I'll put an X in there for it. And then this one will be X times 6.25%. Well, remember, we never want to work with it in percent form, so we want to change that to decimal. Well, here's 6.25%. To change that to decimal form, we want to move our decimal place 2 places to the left. So 1, 2, and we have to put a 0 there. So if you move it to the left and there's no digits there, you have to put a 0. So this becomes X times 0.0625 equals 5312.50. This is like 1x, remember, and this is 0.0625x. So these are actually like terms. They're both x to the first power. So we add the numbers that are in front of them. Well, we got 1 plus 0.0625. That gives us 1.0625x equals 5312.50. And then we're solving for x. Well, this one doesn't have very much to it. It's just last step. Divide both sides by the number in front of your x. So we're going to divide both sides by 1.0625x, or 1.0625, sorry. And let's see what we get. On this side, those cancel. We got x. On this side, we got 53, 12, 50 divided by 1.0625 linear. And we get 5,000. So that would be our cost before they added on the sales tax. Well, let's look at the next problem. A house increased in value by 5% over the last year. The value of the house is now this. What was the value of the house 1 year ago? Well, this is increasing, so this will be a plus problem. So we have our old value plus our old value times it's an increase by, so the percent increase equals our new value. See what they give us. House increased in value by 5%. So they're telling us this is 5%. The value of the house is now $89,250. So that's our new value. So $89,250. And it says, what was the value of the house 1 year ago? So they want to know the old value, which we don't know, so that's x. And this will be x times 5%. Well, again, we want to change our percent to decimal, so that'll be 0.05x. Again, we move the decimal place 2 places to the left. If I were to put a decimal here, again, it's right there. So it becomes 0.05. Combine together like terms at any step. There's an invisible 1 here, so 1 plus 0.05 gives us 1.05x. Now the last step is divide both sides by a number in front of our x. So we're going to divide both sides by 1.05. And these 1.05s cancel. And let's see what we got. 89,250 divided by 1.05. We get 85,000. And that'd be our answer. I'm not sure if I have room there. Let me start a new page. And let's look at our next problem. Now, not all percent problems fit that form, but specifically ones where you're adding a percent on, like sales tax or something like that, or where you're discounting something by a certain percentage, they fit well with those two forms. This says car dealer had a 20% discount on new cars. A new truck is on sale for $9,600. What was the price of the truck before the discount? So discount, that means we're subtracting. So our old price minus, and then we take our old price times the discount percent. And that's going to give us our new price. So let's see what they give us. Car dealer had 20% discount. So this would be 20%. New truck is on sale for $9,600. So this is the price it's on sale for. So that's our new price. Then it says what was the price of this truck before the discount? So that's our old price. So that'd be x, and then this would be x times our 20%. Well, again, we want this in decimal form, so here's be my decimal here. I'd move it 2 places to the left. So this would be 0.20x, or just 0.2. 9,600. Now we combine together like terms. This is like a 1 here. 1 minus 0.2 should give us 0.8. I ought to check that because I really do hate decimals, but we'll go with it. It's not too late. Sometimes it gets late at night and I really can't think decimals. Okay, our last step. Divide both sides by the number in front of your x. So we're going to divide both sides by 0.8. And those cancel there. And I think it's 12,000. Let me go put it in the calculator and see. So 9,600 divided by 0.8. 12,000. Okay, so that's our answer. Well, let's look at our last problem. It says in an election, the loser received 75% of the winner's votes. If 1,050 votes were cast, how many did each receive? Now, see how this is not talking about increasing it by a certain percent or decreasing it by a certain percent. So this one isn't referring to what we're talking about before at all. It says in an election, a loser received 75% of the winner's votes. So it sounds like loser is being put in reference to the winner. So that kind of leads me to think the setup should go like this. The loser received 75% of the winner's votes. So loser is being put in reference to the winner. The one that's being put in reference to is always your x. 75% of the winner's votes. Of is always multiplication. So this is saying 75% times x. And then total, there's 1,050 votes. So if we add this one plus this one, so let me see, 75% times x plus x should give us 1,000, what did I say, 50? Okay. Now again, we want to change that to decimal. So that'd be 0.75x, and this would be x. There's an invisible 1 here. These are like terms, so 0.75 plus 1 gives us 1.75x. And to get x by itself, we're going to divide both sides by the number in front of our x, which is 1.75. And those cancel. And let's see what this gives us. 1,050 divided by 1.75. So we get 600. That means the winner got 600 votes because they're the x. The loser, if it adds up to 1,050 total, then this has to be 450. And let's see what they were even asking for. How many did each receive? Okay, so that does answer what they're asking for. Now, this section actually has a very practical application. My wife lost her job because of some medical issues, and I worked weekends at a motel doing third shift. The easiest job I've ever had. I basically had to do 45 minutes worth of work, and then the rest of the time was watching TV, eating free food, because that was part of the perks. They said you could help yourself to free food, and since we didn't have a whole lot of money right then, that free food was kind of nice. Some of the things I couldn't afford at home, I partook of. They had orange juice, and I drank enough of that the first night I kind of got sick of it and didn't drink it anymore. Milk, I drank lots of that. I had Rice Krispie snacks. Those are expensive down at Walmart, so I was shoveling those in. But anyway, back to the 45 minutes worth of work. One of the things that you do is they had an adding machine, and when a person came in, check into the motel, you would let's say the room rate was $70. Well, what you do is you type 70 into the calculator, and then you push the tax button, and it would give you the amount that should be posted to the credit card. You know, it wasn't real hard. They had the tax rate programmed into the tax button. Well, some people would forget to push the tax button, and they would just post $70 to the credit card. And they did all this by hand, did the paperwork by hand, besides the adding machine. And then later on they would go and put it into the computer. Well, what the computer was wanting is they were wanting the room rate to be input. They weren't wanting the total. So what the formula looked like, I think back then the tax was 14.1%, and then this is the total. So the computer system was wanting you to put in the room rate, and then it would give you the total. Well, since they had done it over on the side on the adding machine, they basically had this over here on a 70. So they had to work backwards to get the room rate. Well, they never were very good at it. They would guess. They'd try $65. That wouldn't give them their 70. So they'd back it out to try another one. They'd try 67. Didn't work. They'd try 50. They'd try whole kinds of different combinations. I'd come in and they'd say, we're stuck. This is what happened, and we can't figure out what this room rate should be. And then I'd say, okay, no problem, I'll do it. And I'd fix it. I never did tell them how to do it. I suppose that was keep the mystery there. They thought I was some kind of mathematical genius. Keep the mystery there so I can keep eating free food. It was the easiest job I ever had in my life. 45 minutes. It wasn't even a hard 45 minutes worth of work. Well, what you do is you set up an equation. This is x plus x times, change that to decimal, 141. And it actually even gets easier. You don't have to actually do the math, because when you combine these together, it always gives you 1.141x. So basically, if they had just taken their $70 they put in and divide by 1 point and then your decimal for your tax rate, that would give them how much they put into the computer. Now you may be asking, well, why didn't they just put in the computer in the first place? Why are they doing it over on the side? Well, the computer system was a little bit slow, and to check somebody in may take you about 10 minutes. Well, imagine sometimes they get kind of busy. Imagine you have 2 people in front of you, maybe 3 people, and they're getting checked in. Well, 3 times 10 minutes would be 30 minutes. They're not going to wait for 30 minutes. So the idea is to get them checked in as fast as you can. So that's why they use the adding machine. And then later on you do the computer work. Well, as you can guess, by doing that, they had errors that happened like this. So the night audit would have to fix that. Occasionally I screwed it up. I didn't screw it up this way because I know how to fix that math-wise. But I would forget to, they'd come in and want for 2 nights. And I'd say, no problem. And I'd do all this correctly. And go to input it into the computer later on, and I'd find that that room was booked for the second night. So again, it wasn't a great thing. It's best to use the computer, but if your computer's down for one thing, or if it's slow, that's another case where you wouldn't want to use it directly. Now people will wait for a period of time if you're at a fancy motel. One time I went to a Hilton, and they had me wait for, I think, an hour. They said, come back in an hour. It's like, okay. And, there you accept it. But when you're talking about a place that charges $70 a night, even though that's not cheap, it wasn't even like a bad motel I was working at. People don't want to wait. They'll go next door to the other one. So, anyway, very practical application. If you know how to solve these percent, you can do some mathematical magic in the motel business. That's our last problem there. So let me go ahead and save this.